Hi guys, welcome to Transcended Institute. So in this video, I want us just to solve quiz 1 for 2024, Math 1120. Okay, so I've got a number of questions here, and the first question is saying, that is part A1, x plus 3.323. So this is 2, though it's not visible, but this is 2. So it is 0.323, then the bar is only covering 3 in the form of a over b, where a and b are a member of what? Integers, and b should not be equal to 0. Okay, so we do know that if we have got something which is this and the bar is covering that, the first thing we have to shift this to the nearest bar. Now, these are the questions that you need guys to know. So whether you like it or not, in your quiz 1, you are going to find the question that is going to require you to express it in a form of a over b. So it is coming, exam is going to be there, in test 1 is going to be there, quiz 1 is going to be there. So this is the question that you need to know it. Okay, so 0 point, the first thing I have to shift this point to the nearest bar. So it will be 10, x being equal to now 3.23, then there's a bar. Again, another thing, I have to shift this to go to here. So it will be how many? I've moved 3 steps. That is 1000 x being equal to 323.23. Now when you do this, you can put the big number on top. So it will be 1000 x being equal to 323.23, then I put a bar. Then here it is 10x being equal to 3.23, I put a bar. Now I can do minus here. So if I do minus, I do know that 1000 minus 10, it should be 990. Okay, 1000 minus 10 is 990. So 990x should be equal to, here these guys are going to be 0, they will cancel out. 3 minus 3 is 0, so I'll have 2, then this, divided by 9990, even here 9990, these will cancel out. X will be equal to 320 divided by 9990. But it's supposed to be in a simplest form. Now this is a rational number. So what is a rational number? A rational number is a number that can be expressed in the form of a over b, where b is not equal to 0. Then these numbers are supposed to be integers. At the same time, they have got no common factors. So if at all there is a number that enters into 320 and 990, then I have to divide. I have to reduce it, because if I leave it in this way, then that is not a rational number. It is not in its simplest form. Okay, meaning there is a common factor, there is a number that can enter into both 320 and 990. If I look at it, I think 2. So I'll say x will be equal to 2 into 32. So if I say 2 into, same as I say, just 2 into 1, 3 is 1. Remainder 2. 2 into 12, 6. Then 2 into 0, 0. So it's 160. Okay. 2 into 9, 4. Carry what? 2 into 9 is 4. What's the remainder? 1. 2 into 19. 2 into 19 is 9. Carry 1. 2 into 10, 5. So meaning, here now I have got 5 here. So 2 can't enter. Then I've got 0 here. 2 can enter there, but 2 can't enter there. Okay, so then I can leave it there. So if I leave it there, I'm going to say that is my answer. So I'm going to end here. This is my answer for part 1. So this question is coming, whether you like it or not. Try to follow those simple principles, and of course you'll be able to see what is happening. There will be no exam, or there will be no test 1 without this question we're going to solve now. In quiz, yes, sometimes it might miss, but in test 1 and exam, you can't find exam or test without these questions. It's not possible. So these are the things that you guys are supposed to know. Know the basics. Know how to solve. This is to the power 2. Simplify it. So the first thing, expand. That is the same as 3 to I. Again 3 to I. Now we were expanding. 3 times 3 is 9. 3 times negative that is 6i. Negative 3 times that is negative 6i. Negative 2i times 2i is 4i squared. And we know that this is going to give me 12i, and that is going to be minus, because we know that I squared is negative 1. So where there is I squared, put negative 1. So it will be negative 4 now. 9 minus 4 is 5. So now what we are trying to find is 5 minus 12i plus 4 minus 2i divided by 1 plus I. Again, one thing I want you guys to understand is that whenever you are going to write a quiz, make sure if the coverage is based on tutorial sheet 1, make sure you know all the questions from tutorial sheet 1. Because some questions they are going to get direct from tutorial sheet. They are not going to change anything. So it's better for you to understand and solve all the questions from tutorial sheet. If at all you don't have the solutions, I solved the tutorial sheet 1, and all the tutorial sheet are going to be there. Now, if you want to access the full topic video, the full tutorial sheet solutions, I have the solutions on website. Check the link in the description. Go to our website and go to math. Any of your math, like if it's math 1100, math 1120, you are going to see the tutorial sheet are there. Full solutions. Even the full solutions for this quiz for 2024 is also there. Okay, so you can access it from there. Now let's continue. So here, what we're going to do is first we have to rationalize this, because we want to put the answer in a form of what? A plus bi. So I'll rationalize this. So I need to get the conjugate, which is 1 minus I. What do I mean by a conjugate? A plus bi, the conjugate is A minus bi. Where there is I, change the sign. That's the conjugate. Even here I'll do the same. This will come the way it is, plus, now I'll multiply. 4 times 1 is 4. 4 times I is negative 4i. Negative 2 times this, negative 2i. Then that and that, plus 2i squared. I divide this. I mentioned in the previous video that if you are multiplying anything by its conjugate, it's basically the same as squaring the part having negative. So if I square this, this is going to be 1 minus I squared, of which I squared is negative 1. So I end up having 2. This 2 is the same as even if I say 1 times 1 is 1. 1 times negative I, negative I. I times 1 is plus I times I, negative I squared. It's the same thing. So these will cancel, and I will remain with this. You see, huh? So now that is the same as negative 1, so I put negative and I'll end up having 2. It will be negative 1 plus 1. It will be 1 plus 1, so not negative, but 1 plus, because this and that is going to give me positive. So this is 2. So this 5 minus 12i will keep on coming, plus. I do know that where there is I, there is negative, so that is now negative 2. So 4 minus 2 is 2. This 2 is negative 6. I divided by 2. What does it mean? It means that I have got 5 minus 12i plus. I've got 2 divided by 2 minus 6i divided by 2. So 5 minus 12i plus 2 into 2 is 1. 2 into that is 3i. Now I can add this. This and that is 6. Then this and this is 15. So this is the answer. Now this answer is in the form of a plus bi. As simple as that. So that's question 1a. So let's now dive into 1b, which is talking about set interval notation. Again, let me repeat myself. There is no quiz and there is no test 1 without set interval notation. You are going to find it. So please know these questions. It's very important that you guys are supposed to know this. You're going to find it in your exam, you're going to find it in your quiz, you're going to find it in your test. This quiz, which is coming right away, you are going to find this type of question, but it's going just to have different figures. Now the question is saying, given that the universal set x is from negative 20 to 20, both included, and that a is negative 1 to 20. Okay, so negative 1 to 20, this is not included. This is not included. B negative 7 to 9, both are included. C is negative 20 to 1, negative 20 to 1, both are included. Union, this is 8 to 14, both not included. Find the following sets. So let's start with the first one and display them on the number line. Okay, so the first thing is we need first to come up with a universal. So what is our universal? So our universal, we don't put arrows if at all the universal has been given the numbers, or if it is not from negative infinity to positive infinity. We only put arrows when we're talking about infinity. So in this case, I'll say the universal, this is included and this is also included. So this is 20, negative 20, and that's positive 20. What should I do? To demarcate these lines, I'll put 0 in between. So we want to find a complement. So what is a? A is from negative 1. I'll put negative 1 here all the way to 20. Now that is a. But negative 1 is not included. So from here all the way to that point, that is a. But we want a complement. A complement means that this should be included, since a is not part of it, going to that side. But this should also be included. That is a complement. And I'm not interested in a. So I'm going to remove it, because I'm not interested in it. What of b? B is from negative what? That number there is not visible, but it's 7. Negative 7 to 9. So I'll put negative 7 here. Then I'm going to put 9 here. So from negative 7 included all the way to 9 included. That is my b. We want the line where b and a complement meet. It is this point. Therefore, a complement intersection b is equal to, starting from 7. So the last point here, it is included. So starting from negative 7, comma, it ends on 1, negative 1. But negative 1 is also included because this is included. So that is the answer. So as you can see, I've found the answer. I've also displayed it on the number line. So where I've shaded, that is a complement intersection b. we get max. Let's go to part 2. Okay, I'll get rid of this to have enough space. So I'll have my line here. The universal from negative 20 all the way to 20 included. So be careful on how you represent this universal, which is, we have been told that is x. Even the previous question you indicate that that is x. That's the universal. Put 0 to demarcate the positive side and negative side. Now here we have got all the things. So the negative side we have got negative 1, negative 7. Okay, so I've got negative 1 and negative 7. The positive numbers, the smallest number is we have 1. So I'll put 1 here. What else? We have 8 and 9. What else? 14. Like that. So we have 1 here. Do we have 1? Positive 1? Yes, we have. Now, the question is, we know that if we have A minus B, it's basically the same as A intersection B complement. So this means that this is the same as A intersection B complement. I put them in the brackets, intersection C. Simple. Meaning that now, if I want to work around with this, the first thing I have to look at what my A is. What is my A? My A is from negative 1 all the way to 20. Negative 1 is not included, so I have to put an open. 20 is included, we already know that. So that's the point. So that is my A. Okay, that is my A. What else? Another thing that I have to take note here is I want to find what my B complement is. My B is negative 7 all the way to 9. Okay, so from negative 7, both are included, all the way to 9 here. In between here, that is B. But we want complement, meaning that starting from this point, since this is included, then that will not be included until the last one I just follow the way it is. That is my B complement. Another B complement will start from here all the way to that point, B complement. But I do not want to show this. So this can go. There is no B, but we have B complement. So now I'm going to shift this to just come here. Even this just to come there. What else? Now we look at C. C is telling us from negative 20 all the way to 1. So negative 20 included, we already know that. All the way to 1. 1 is here, now straight here. Included. We put the line. That's the line. That is A. Another one. So now they have jumped again 8 all the way to 14. So from 8, not included, all the way to 14, not included. Again in between. That's my A. Inside there's intersection, outside there's intersection. What does it mean? We want a line where all the three guys are meeting. Where A, B complement and A, they are meeting. So I can clearly see that the only point where the three lines are meeting is this point here. Only. It's this point. Up to that point. That's the only point. So that point I've shaded, that is A, minus b in the brackets intersection c, meaning that a minus b intersected with c is equal to, this is 9, but you look at the last line, which is this one, it is open, so it will be 9 open. Then again, this is the a, that's where it ends, so here also is open, so it is 14. So that's the answer. They are both not included. Okay, so that is it for part B. So try to explore different type of questions based on the same concept, and you're going to see if you'll be able to answer them. Yeah, if you are still having some challenges, try to watch different videos from our YouTube channel. We have got different videos under set interpretation. I believe you're going to be helped. Okay, now let us go to part C, which is saying express. We have got 2. Okay, we have got we have 2 on top there. No, it's not 2, it's 12. So this is 12. So 12 minus 3 root 2 divided by 3 plus 2 root 18 minus 3 root 2 in the form of, we express it in the form of p plus q root of, this should be plus, root of 2, where p and q are integers. So now the most important thing here, we look at, we're just trying to rationalize the denominator. So then, trying to rationalize the denominator, but bottom here we have got 2 square root and I've got different numbers. The other one has got 2, the other one has got 18. What we normally do here is get the big number, divide it by that big number which is in the square root. So you divide it by the smallest number that is in the square root, that is 2. In that case, I'm going to get 9. So 9 times 2, it is 18, meaning that the square root of 9 times the square root of 2, it is still 18. Then that can be written as 12 minus 3 root 2 divided by 3 plus 2 root 9 times root 2 minus 3 root 2. Then the top part will not, it's not going to change. It's going to be like that. Then it will be 3 plus 2, then times the square root of 3, 9 is 3 root 2 minus 3, like that. So we have 12 minus 3 root 2 divided by 3 plus 2 times 3, 6 root 2 minus 3 root 2. Now I can clearly see that I've got now root 2 root 2, so it can be added. So now I have 12, this, I divide this by 3, so I'm doing 3 minus 3. The root is going to remain the same. 3 minus 3, or 6 minus 3 is 3. So I'll have this. Now I can rationalize the denominator. To rationalize the denominator, get the conjugate of the denominator. If it is negative, put the positive in between. What you have done there, do the same. Now multiply them. 12 times 3. What is 12 times 3? 36. 12 times 3 root 2, it is so you do 12 times 3, that is still 36 root 2. 3 times 3 is negative 9 root 2. Negative 3 times that is going to give me same negative 9. Now root 2 times root 2 is just 2. Root and root will cancel. 3 times 3 is 9, but if you want you can square the part having negative, it's the same thing. 3 times 3 is 9, 3 times that is also 9 root 2. This and that So this is supposed to be plus, then this is going to be minus 9 root 2. That is going to be 3. 3 times 3 is 9. 9 root 2 times root 2, it is 2. So then it's going to be 36. These two can be added. So it's 36 minus 9. Okay. 36 minus 9 should be 27. So it's plus 27. Then this one is now 18. 9 times 2 is 18. I divide that by, so this they'll cancel. This minus that is 0. So here I have 9 minus that is 18. I can get rid of this to have enough space this side. These two can be added. Okay, so 36 minus 18 is 18. So I have 18 plus, when I add this, I forgot the square root. So this and that is 27 root 2. So it's 27 root 2. Okay, divide that by 9 minus that is negative 9. Now we have 18 divided by negative 9 plus 27 divided by negative 9 root 2. The next thing that you do, divide them. This one there is 2. This one there is 3 root 2. This is the answer. So I believe you have managed to follow through and try to again explore different type of questions based on the same concept, and I believe it's going to help you out. Okay, now let us dive into question 2, which is talking about functions. So question 2a is saying find the domain of each of the following. So we're just trying to find the domain. So the first part here, this is what we call a rational function. So this, in case you are not able to see, it is 2. It is 2x squared. So initially the equation is f of x is equal to 7 divided by 9x minus 4 minus 2x squared. This is what we call a rational function. Now, how do we find the domain of a rational function? To get the domain of the rational function, you can never have a situation of f of x is equal to a number over 0 or 0 over 0. This is undefined. To make the function defined, we should take note that the denominator should not be equal to 0. So to find the domain of any rational number, get the denominator the way it is. The way it is set not equal to 0. The denominator should not be equal to 0. So for x, in this case, I can arrange this to be the same as negative 2x squared plus 9x minus 4 not equal to 0. Let's now solve for x. Reaching at this point, we know that we are going to reach at the point of product and sum. Product is negative 4, negative 2 times that is negative 8, positive 8, sorry. The sum is positive 9. What are the factors? So the factors should be negative 8 and negative 1. Is this going to be okay? No. Both should be positive. If this is positive, that is positive, meaning negative positive 1 times positive 8 is positive 8. The 8 plus 1 is 9, yes. So now I have got negative 2x squared plus 8x plus x minus 4 not equal to 0. We are solving for x. Let's factor out negative 2 here, x. I factor out negative 2x here, I remain with x. then minus there, 2x there is going to be 4. Not 4x, but just 4, because x we have already here. Here I'll factor out 1, I have x minus 4, not equal to 0. If these are the same, you choose 1, you write 1, not you choose, because they are the same. So I have this and that not equal to 0. So we are solving for x, negative 2x plus 1 not equal to 0, comma, x minus 4 not equal to 0. We continue from here. Now we are going to shift 1 to the other side. Negative 2x not equal to negative 1. I've shifted 1 to the other side, it's now negative. Divide by negative 2, negative 2x should not be equal to 1 over 2. I'll leave it here. Another one, we are also shifting 4, negative 4 to the other side. Then x should do not be equal to 4. So I have two numbers. Now, how do we write the domain? These are just the values, but how can x can be any number. Okay? X can be any number except half and 4. That's all. Okay? So x can be any number except half and 4. So in that case, how are we going to solve? How are we going to represent our answer? Okay, that is important, guys. I want you to know. So you can report the answer in two forms. There's what we call set builder notation or in set interval notation. So you choose which one to go with. So in this case, I'll go with both. Okay, I'll go with both. I'll go with both. So I'll start with set interval notation. So the domain is it has to start from the values that can fit are only from negative infinity all the way to 1 over 2. So I don't have enough space. Let me just do it this side. The domain should be starting from negative infinity. Any number can fit all the way to 1 over 2, but 1 over 2 is not included. Any number from negative infinity to 1 over 2 can fit, but 1 over 2 is not part of it. That's why it is open. I have not put in. So negative 1 over 2 is not included. Union. Any number from 1 over 2 to 4, it can fit. But 1 over 2 and 4, they are not part of it. That's why I've used open. Again, union. Any number from 4 all the way to positive infinity can fit, but 4 is not part of it. This is the domain. I can also use set builder notation and say x is such that x should not be equal to half and x should not be, so you can put and in between, and x should not be equal to 4, but x should be a member of all real numbers. But the best way to present this is the set interval notation. Okay, so here in between you can put and. So you say x should not be equal to half and x should not be equal to 4, but x should be a member of all real numbers. So you choose which one to go with. That's how we find the domain of a rational function. Okay,